This is podcast number 2 for chapter 16. In this podcast, we're going to take a look at what is actually happening during the process of respiration. So with respiration, you're basically having a couple of different processes happening at the same time. So pulmonary ventilation is basically what you're doing when you're breathing. You're moving air in and out of the lungs. And we can break that down into two parts. There is the external respiration piece, and that is where the gas exchange is actually going to happen between your capillaries that are surrounding your alveoli and the alveoli themselves. And then there's also the internal respiration, and this is actually where we're going to exchange gases between the blood and the tissues of your cells. And this is going to happen through the systemic capillaries that are found all throughout your body. So again, we have to move the air in and out, and then we have to do the gas exchange from the air into the blood, and then from the blood into the actual tissues. So in order for breathing to occur, there's two stages of pulmonary ventilation. There is the inhalation or inspiration, that is the flow of air into the lungs. And then expiration or exhaling is the air leaving the lung. So when we inhale, what actually happens is our diaphragm, which is a flat muscle that is at the bottom of the lungs, is going to contract. And when it contracts, it moves down. And what it does that, when it moves down, it actually, so normally it would be kind of up, and then it moves down a little bit, and that is actually going to increase the volume of our thoracic cavity. It also is going to change the pressure and decrease the pressure that is in the cavity, and the air gets pulled into the lungs from a high to low pressure. So as the diaphragm contracts, it moves down, and also you have a bunch of muscles in between your ribs. Those are also going to contract, and those are going to raise your rib cage. And basically what it's doing is it's allowing for enough room for your lungs to inflate like a balloon, and it's also changing the pressure which is going to pull the air in. So when we look at inspiration, again, the diaphragm is moving down, the ribs are going to move up and out. Okay, and our rib cage gets as wide as it possibly can. Whereas the opposite of that is our exhalation, and this actually is a passive process. Air is going to get pushed out of the lungs kind of naturally. The diaphragm is going to relax, so it's going to go back up in its position. Your rib cage is also going to relax, which is going to decrease the overall size of the thoracic cavity. And air thereby is going to get pushed out of the lungs. So basically, you can think about squeezing a balloon, you're going to push the air out of the balloon. When the rib cage comes down and the diaphragm moves up, you're making less space for the lungs to have air, and so everything gets pushed out. Forced expiration can occur mostly by contracting your muscles of your rib cage. So you can make yourself breathe out as much as possible by kind of pushing in your ribs as far as you can, and that will push out as much air as you possibly can. Okay, so when we exhale, you can see a little difference here. The diaphragm is moved way up, our rib cage is coming down, and now everything, the whole area inside the thoracic cavity is much smaller because everything has moved in. Now that's just getting the air in and out of the body, but we also need to be able to get the oxygen that we need for our cells into our blood. So the first place where we're going to get the oxygen into our blood is going to happen in the lungs, and this is called external respiration. So the alveoli, when we breathe in, is going to have more oxygen in it than the blood. So the oxygen is going to diffuse towards the area of lower concentration. Okay, and so all of the capillaries that are surrounding all the alveoli are going to gain that oxygen. So when you breathe in, you have more oxygen in your lungs than in your blood, so the oxygen diffuses, moves from a high to low concentration. This whole process works in that way, and it ends up in your blood. At the same time, carbon dioxide is going to be exchanged for that. So the blood that is returning from the tissues has already dropped off as oxygen, now has large amounts of carbon dioxide in there, because carbon dioxide was a waste product of cellular respiration. So the capillaries are going to give the carbon dioxide up and put it into the alveoli, so that the blood that is leaving the lungs is now going to be oxygen rich, because it just got it from the air we breathed in, and carbon dioxide poor, because you just put it back into the lungs, and then we breathe that carbon dioxide out. Okay, so once the gases get into the blood, the way that they get transported, oxygen gets transported by being attached to hemoglobin on your red blood cells. So most of the oxygen, when it gets taken into the blood, is going to go over and basically hitch a ride on hemoglobin, which is part of the red blood cells. There is a small amount that can be kind of dissolved in the plasma, but most of it is going to get attached to the red blood cells. Carbon dioxide transport's a little bit different. Carbon dioxide transport happens mostly in the plasma, and it actually gets converted into something called a bicarbonate. The bicarbonate can be quite acidic, and so if too much carbon dioxide builds up in your blood, you're going to have a large amount of bicarbonate, and that can lead to an acidic blood, which can cause damage to your blood cells. So if you hold your breath, you're actually not going to have damage from lack of oxygen. You typically will have damage from buildup of carbon dioxide. Only a small amount of carbon dioxide is actually carried on the hemoglobin at different spots than those of oxygen. But most of it is dissolved in the plasma, so it's kind of the opposite of what happens with oxygen. Carbon monoxide is, instead of CO2, it's just CO. Mimics oxygen. So the reason carbon monoxide can be really dangerous is if you're breathing in carbon monoxide, it will attach to the hemoglobin where oxygen is supposed to attach, and then oxygen can't attach there, and you're not going to transport oxygen around the way you're supposed to, and that's why carbon monoxide poisoning can be deadly. Now, internal respiration, this is going to be the exchange of gases between the blood and the actual cells of your body. So it's the opposite of what occurs in your cells. So during cellular respiration, your cells are producing carbon dioxide. So that carbon dioxide has to leave your cells of your tissue and go into the blood. And the cellular respiration needs more oxygen in order to keep going, so the oxygen is going to diffuse from the blood into those tissues so that they can do the cellular respiration. But this is going to happen at all the little blood capillaries that are found all throughout your entire body. So you're taking the oxygen in, you got to get the oxygen into your blood, and then that oxygen has to get into your individual cells. And that's kind of the pathway that it takes, and then the oxygen is used, ends up kind of becoming part of carbon dioxide, and then we have to get rid of that carbon dioxide. Okay, so this is showing you the difference between internal and external. So here is our external respiration, what is happening here. So here we have our air sac and the capillary right here with the blood in it. Okay, so the oxygen is going to go out of the alveoli and attach to the hemoglobin on the red blood cells, because remember there's more oxygen in the alveolus than there is in the blood, so it diffuses that way. The carbon dioxide is going to go in the other direction because there is more carbon dioxide in the blood than in the air sacs, so the carbon dioxide is going to move into the alveoli so that we can breathe it out. Whereas in your tissues, remember your tissues are doing a whole lot of cellular respiration, so they're producing a lot of carbon dioxide, so there's more in the cells than in the blood, so the carbon dioxide is going to leave. And the red blood cells are going to let go of their oxygen, and they're going to get diffused into the cells where there is less. So the whole purpose of the respiratory system is what you're seeing on this slide. We have to get oxygen in, basically ultimately to our cells so that they can get energy, and we have to get rid of that carbon dioxide, which is basically a byproduct of or a waste product of the cellular respiration process, which we need in order to get our energy in the form of ATP.